Imagine stepping into a doorway on Earth and coming out near another star system in seconds. No rockets, no years of travel, no frozen astronauts, just space folded like paper. That idea is called a wormhole. It sounds fictional, but wormholes are not born from movies. They come from real equations of physics. In 1915, Albert Einstein described gravity as the bending of space and time. Later, scientists realized those same equations allow strange shortcuts in space-time, tunnels connecting distant regions of the universe. These theoretical tunnels became known as Einstein, Rosen bridges, or wormholes. Instead of traveling across space, a wormhole lets you pass through space itself. Picture the universe as a sheet of paper. Normally, you move across the surface. But if you fold the paper and punch a hole through it, two distant points suddenly touch. That hole is a wormhole. Now imagine what happens if such structures exist. First, distance stops meaning what it used to. A star 1,000 light-years away could become closer than the moon. Space travel transforms from endurance to navigation. Civilizations would explore galaxies the way ships explore oceans. But wormholes are not simple tunnels. According to physics, natural wormholes collapse instantly. Gravity squeezes them shut faster than light can pass through. To keep one open, scientists believe you need something called exotic matter, material with negative energy that pushes space-time apart instead of pulling it together. We have never found large amounts of it. But quantum physics shows tiny negative energies can exist. That means wormholes are not forbidden, just extremely difficult. Now comes the wild part. If a wormhole stays open, it could also distort time. One side could experience time slower than the other. Entering one end might throw you into the future or the past relative to Earth. That connects wormholes to time travel theories. Stephen Hawking even warned that stable wormholes could break causality, allowing effects to happen before causes. That's why many physicists think nature may prevent usable time travel wormholes from forming. So could humans teleport through one? In theory, yes. If a wormhole is stable, wide enough, and protected from radiation, anything could pass. Particles, spacecraft, even people. But the interior would be extreme. Tidal forces might stretch objects like spaghetti. Radiation could flood the tunnel. One wrong fluctuation could collapse the entrance instantly. It wouldn't feel like teleportation. It would feel like falling through distorted space where direction, gravity, and time lose meaning. Some scientists believe microscopic wormholes may already exist at the quantum level. Space itself might be foamy, filled with tiny tunnels appearing and disappearing constantly. We cannot see them, but they may shape reality underneath everything we observe. Others connect wormholes to black holes. A rotating black hole could, in theory, contain a passage to another region of spacetime. But any real traveler would be destroyed long before reaching the center. So wormholes might exist, but nature hides them well. Now imagine humanity learns to build one. Suddenly, Earth is no longer isolated. Mars becomes next door. Other star systems become reachable in days. Colonization explodes. Trade across galaxies becomes possible. Human civilization stops being planetary and becomes cosmic. But danger grows too. If wormholes connect locations instantly, they also connect threats instantly. One mistake could invite radiation, unknown physics, or even hostile environments into Earth's neighborhood. A wormhole is not just transportation. It is exposure. And the biggest risk is control. Once space is folded, you are no longer traveling through space. Space is traveling through you. So what happens if wormholes exist? Distance collapses. Time becomes flexible. Exploration becomes radical. And the universe turns from unreachable into navigable. But until exotic matter is mastered and space-time engineering becomes real, wormholes remain on the edge between science and imagination. They are not doors waiting to be opened. They are questions waiting to be understood. And if one day humanity learns to bend space-time itself, the first place we won't travel to is far away. It's everywhere at once.